This is lecture number 7. So today we will cover some of the property about document, and also how do we process the languages, how do we compute entropy of the symbol to determine the meaning or the information carried by this symbol. So this is useful when we want to determine whether some symbol or some term is important or not to be kept in our vocabulary. So the outline will be, we look into the metadata, which is the information about our data, and also the format of the document, and text properties and document pre-processing. So these are the 4 main topics that we will cover today. Okay, for each of the document that we have, we see that we can see the syntax, which is the meaning or the information carried by those symbol or term in the document, and also we have the structure. The structure referring to what field or what type of information are stored in that particular page. For example, we must know what is the topic, where is the location of the topic, who is the author, and so on. So the structure of the document will tell you where to find those information. We also have semantic. Okay. Just now I said this is meaning. Basically, this is the grammar, the syntax and structure. So semantic referring to the meaning. So in the document, we must have the format on how do we represent the document, the format, and also we must know what is the meaning, right? So how do we actually extract this information, given that a system that you develop would be able to know what is the format and which term carry more information. So that's why we need to know the syntax and structure, the grammar and the format of your document. And at the same time also we need to be able to see which term are more important, which term can be used to retrieve the document. So the document syntax referring to the structure, how do you set the style for the presentation, and also we look at the meaning of a certain term that we have. For example, this is your document, and inside your document you may have text and other media. Okay. So you must know what is the syntax, what is the structure. So because the structure will give you what is the presentation style, the structure, and also the semantic. So these are the 3 things that will be extracted from the syntax. Okay. So one or more of element might be implicit or given together. So for example, we can have the structure and semantic together, or we can have the presentation style and the semantic together. So for example, in each of the document, the top one could be the title, okay, and followed by the author of the document. So the document style defines how a document is visualized or printed. So if you see that the Microsoft document referring to what you see is what you get, right? So we also have these scientific tools that we can use, for example, LaTeX. You need to do some pre-formatting in order to show that that is the topic and who is the author, what is the section, and so on. So for example, on your right-hand side, it tells you the chapter 6. So chapter 6 normally have large font and then introduction and so on. So maybe bolded. So for example, in LaTeX, we normally pre-format them by saying that this is the section. So this is the section and label and so on. So we have this percentage, we cite from what document and so on. So we already tell the system that, okay, based on this, we know that we are citing from this, we are citing from this and so on. So when you run the LaTeX or execute the program, you will see something like this. Okay, so you see the section here will have different color, and also the reference here will be automatically get from the list of reference that we have. Okay, so query in the search engine could be considered a short piece of text, so different from the normal text. So what we want to do is we want to know when we do some query, the term referring to what aspect or in what context the word being used. For instance, bank could refer to bank of river or bank account. So when we see a single term here, it's not enough for us to infer what does this one meaning. What is the meaning of the bank? So we need to see how the bank is used in the context of the other term mentioned in your query. So bank of river, bank account, and so on. Okay, so that's why we need to know about metadata. This is the information about your data. So we can define metadata as the information on the organization of the data, or the various data domain and how they are related to each other. So metadata is actually data about your data. So if we compare in database, all of you have taken database, right? So we have relation, table, and attribute. So these are the metadata that we could extract from your database. But in text document, we have some other information. For example, we want to know who is the author, when the paper is published, and who is the publisher, and number of pages, and what is the topic and the content of the document. So these are the information about your data that we need to extract. How do we know how to extract this? So we need to know the format of your document. So in most cases, we have this catalog card. So metadata is associated with most document and text collection. For example, over here, we have the place of publication. We have the call number. So we normally use the call number to look at we starting from what alphabet, and then where is the location, who is the author, what is the title, and so on. Okay, so from this card catalog, we want to transfer this one into the digital format. Can we extract this information automatically from the document? Okay. But some of them we can extract automatically, and most of them we need to create a database and then manually key in. Okay, so we have this catalog card. So when we talk about the semantic metadata, they actually characterize the subject matter within the document. So semantic refer to the meaning of your metadata. Or for example, we have this machine readable cataloging record. So in which we use this format in order for us to extract those information. So this is the author, the title, and many more. Okay. So based on this information, normally when we type our keyword, they will try to match to retrieve the most relevant document. Okay. We can do exact matching, or we can do based on the title, or based on the description of the document that we have. So this is machine readable cataloging record, in which they are converted into digital format already. Okay, that is for the book or journal or papers, but most of our information coming from the web, right? So we also need to tag what kind of information that we can take from the web. So the increase in web data has led to many initiatives to add metadata information to web pages. So this is important because normally you want to map your IP or digital signature, or you want to include your item in the e-commerce because you want to promote, right? So you need to, you want to sell your product, so you need to provide as many information in order for your product to be visible out in the market. Okay. So in the semantic web, they use this resource description framework. This is a new standard for web metadata. They allow you to describe the web resources to facilitate automated processing. So the concept is we need to have the resource, the property, and the values. So, for example, based on this URL, we can get the what method is used to retrieve, and also we have the location where is the resource reside. So up to here, and then this is the resource. Okay, so this one will give you the resource. Okay, so the whole thing is called URL, which is the Uniform Resource Locator, and we have also the Uniform Resource Name, which is up to here, that tell you the method and also the location. Okay. So the whole thing is called URI, Uniform Resource Identifier. So URI will tell you what is the method being used, where is the location, and what type of resources are you trying to retrieve. Okay. So basically in the RDF model, we need to have the resource, properties, and statement. So the resource is all the things that being described by RDF. What resources do you have? And then what is the property that you are trying to state here? And then what are the values? For example, like this, we use 3 tuples to represent resource, properties, and values. So normally they are 3 tuple representation, the predicate, subject, an object. So for example, the author of this document is Jane Sarella. Okay? So how do we define this in the RDF? Is that we have the resource here. This is your resource, and this is your property, and this is your value. So this is how we represent the tree tuple in the RDF model to state what resource do we have, and what is the property, and what is the value. So these are some of the basic information that we can know about how the web is being used, and how semantic web is being used to carry or to extract the information from the web-based document. So to study this one, we have another course, what we call semantic web. So they talk about this RDF, resource description framework. Okay? So what we do today is just to look at the surface information only, because we want to know what kind of format and what kind of information that we can document. Okay, so next one is we look at the text properties, information theory. Okay, so what we want to know is how do we determine this is important or not? For example, the is, because when we look at this one, these are the most frequent term that we can find in a document. So when a certain term exists very frequent in your document, that means it cannot be used to retrieve the document because that term is not unique anymore. So in other words, this term carry less information. Okay? They carry less information. But we need to define them. How do we say they carry less information? Okay, so we use the information theory to define a special concept, entropy, to capture information content. So we use this entropy and to prove that these are terms that carry less meaning. So what is this entropy? So for example, we have a whole text, okay, and we have this symbol. So the entropy can be defined as the average, okay, the average calculation of the weight given the probability of each of the terms that we have in your text. Okay, so where pi is the probability assigned by the model to the symbol ti here. So it is important to note that e is a property of the model and not only to the text. So what we want to say is that e is actually the model that we use in order to say that what is how much information that we can get from certain term. Okay, so this is the model that we use. Okay. So to show the example, how do we apply the formula here? So let's suppose we have a closed model. A closed model means we are looking at this sentence only. So we will look at individual symbol that we have here. Okay. So from here, what we can get is that we have 4, 1, 2. So we have U, we have N, I, V, E, R, S, and then I we already have, and then we are missing M. Okay, or this is only for the I. Okay, university only. So we look at this one only. Okay, so the probability of U, this one, is given from 1/23 because the length of this is 23. In Wisdom Leher Sabah, they have 23 characters. Okay, so 1/23. Okay, so the entropy can be computed here by using this formula. So basically, the N here refer to how many symbols we have here. How many symbols? So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, and M, and then no, that is 10. We look at this is the 10 because we have 10 symbols here. Okay, so if we look at that one, when we sum up everything, so this is the entropy that we have. Okay, so that means for each one of these we will say this is for the U, and then this is for the N, I, V, and then this is the E, this is the university. So we have 10 symbols here. Okay, so when we compute, so this is how much is the information that we get. So based on this formula, the higher is the value, the more information carried by those symbols. Okay, so if the probability is high, so for example, if the probability is 1, that means if this symbol is always used, so that means this one should be 0 because log base 2, 1 is 0. Okay, so this is how we determine the information carried out by certain term in our document. Okay, so this can be simplified. So this is similar to what you have here, but this is the look at the summation of the all the symbol that we have. So this is the symbol that we have in our alphabet, and we assign the probability for each of the symbol that we have. So this is tend to be the formula that we use in the entropy. Okay, so the entropy here will tell you more information for that particular term if the value is higher. Okay, the entropy will be 0 if that term always exists and less carry less information. Okay, so your exercise will be given because we have done the university, right? So you tell me what is the value for Malaysia and Sabah, and then you need to determine which symbol is know which term carry more information, Malaysia or Sabah. Okay. So this is your practice. Okay. Now we look at how do we model natural language. I think you have covered some of this topic in your text mining. So more or less similar. So in the natural language modeling, we can divide the symbol of a text in two disjoint subsets, or we can do the tokenization. So we need to have a symbol that separate the word and also symbol that part belong to the word, part of the word. Okay. So in our language, in all of the cases, we use the blank space to separate the words, right? Okay. So in trying to tokenize the document, tokenize the word that we have in the document, we may have some term exist more frequent compared to the other. So we have this zip law that say that the F1 will be your most frequent term that we have. And then the I refer to the second or the third or the rest of the word that we have. So if we say that this is the frequency of the most common term, most common, and not most common, most frequent. Okay, most frequent. So the second one, for example, this is 2, will be half of this because this is 2. Because the alpha one is always 1. And then, for example, if your most frequent word is term 1 is 10, so that means your term 2 will be 5. This is the number of occurrence of term 1, 10 times, and then term 2 is around 5, and term 3 is around 3, and so on, because due to this. Okay. So for a text of n words, so we have this, and basically if we apply this one, so basically for the n words that we have, basically we could add up all of them and get the number here. But how do we compute the most frequent one? So if we try to put this one, so this is equivalent to what we have here. So we can replace this with this one. And then basically we take out the F1 here times this. Okay. So finally we can compute F1 based on this. Because F1 is constant, right? So F1 can be computed, and then the rest of them can be automatically computed based on what you have here. Okay. So based on that, we can say that the most frequent one may carry less meaning, and the less frequent one may carry more meaning. Okay, because if we have the most frequent term here, they always exist in all of the document. That means we cannot use this to retrieve the document. So we might as well focus on this area here, which are the unique term that can be used to differentiate the document that we have. Okay. So for that reason, all the stop words that we have can be disregarded because they occur more frequent compared to the other term. So the stop word is more less like this, the, by, and so all this can be ignored. You don't have to put them in the vocabulary. This is because we want to reduce the size of our vocabulary because that one will affect the computation time. Remember that we have term document matrix. So this is your matrix. So you have all the term here and you have all the document here. So we want to reduce this size. We want to only get the ones that are frequent less in the all of the document. Okay. So when we talk about the text size, so when we have the text size is small, so the vocabulary as we go up here, when the text size is increasing, we can have more vocabulary. But when we have longer text size, eventually we will not be able to draw or generate more vocabulary. Okay, so for example, this term right here. So we never heard about this, right? And this is the longest one. So as you can see, the longer is the size of, the bigger is the text size, we somehow cannot regenerate a new term from this one because this is very specific. So that means for this we only have one vocabulary. Okay. So that means when we go back to the previous slide, when the text size increase, eventually we cannot generate more of the vocabulary. Okay, so we want to have like this. We say, okay, we can limit the text size so that we can capture as many vocabulary that we have. So this is to reduce the number of text also that we use in the text document, or to reduce the number of terms in our vocabulary. Okay. Okay, now we look at the text similarity. How do we compare the text? Okay, we can use this distance function. For example, these two, because sometimes we do the typo like university for I and Y. Okay, so we want to know what is the nearest term that can be used to retrieve the document. So that's why we need to know how to perform the computing the similarity between two terms. Okay, for the distance function, using the Hamming distance, this is how many functions that we use in order to change them. So for example, this one, we have 4 different, this is 1 different symbol, this is 4. So this is distance function. Okay, so we want to see how many characters which is misaligned. So this is Hamming distance. We also have this edit or Levenstein distance. This refers to how many changes that we need to do in order to match them. So for example, like this, we have color and color. So we have one operation here, which is to replace them. And then for this one, we have two operations. So one we substitute V and G, and then one is to delete R. So two operations. This is one and second. So the edit or Levenstein distance referring to the number of changes that we need to make in order to match the term. So this will be used to represent the distance between two different terms that we have. Okay. We also have this longest common subsequent. For example, this survey and surgery. So the longest common subsequent will be sorry. Okay, so this is the benchmark for computing the similarity between survey and surgery. Okay. Okay, so in trying to find the similarity between the document, we can use this resemblance measure. Okay, so this is how we compare the similarity between documents. The previous one is we look at how do we compare the similarity between two texts only. Okay, so now we go into document. Okay. So the similarity between the document or the resemblance can be defined as the number of words that are similar between two documents divided by the number of unique terms that we have in the document. Okay, so the value will be within 0 and 1, and then based on this, then we can find the distance by subtracting the percentage here to from 1. Okay, so the smaller is the value, the more similar they are. Okay, let's take a look at this one example here. We have 4 documents, and the unique item in each of the document can be defined here. For example, document 1, we have A, B, C, D. Document 2, we have A, D, E, F, G, H, I. Document D, we have B, D, G, H, J, K, and then document 4. Okay, so when we compute the value of resemblance, okay, we look at D1 and 2. So D1 and 2, we have 1, we have 2, which are common. And since they are 2 common, so that means we have 5 plus 2 plus 2, we have 9 unique terms. So that's why we get 2/9 here. Yeah. So for document 1 and 3, so we can see that document 1 and 3, let me use different color. So document 1 and 3, we have B, and then we have D. So only 2, so that's why we get 2. So when you combine the unique terms, so we have 4 here. We have 2 here, plus this, and this we have 2. So altogether 4. So that's why we get 4 here. Okay. For the D1 and D4, so we have 1, and then D. So we have 2, and then the unique term will be 3 plus 1 plus 1, 5 plus 1, 2, so 7. Okay. So this is the resemblance measure. So the distance will be 1 minus that number. So the smaller is the distance, the better is the similarity here. Okay. So this is your practice. So they said, okay, given this document 1, document 2, document 3, and 4, find the lowest and the highest distance. So the one that we did previously, we only do 1 and 2, 1 and 3, 1 and 4. So you need to find this, you need to find the 2 and then the 3, not D2, D3, and then D2 and D4, and then finally D3, D4. So you need to find 3 more, then tell us what is the lowest distance and what is the highest distance, which the 2 documents have the lowest distance and highest distance. Okay, so just do this practice. Okay, so when we know about the term that we are looking at, so we normally look at the meaning. We also look at how frequent they are. Okay, so we need to know what are the pre-processing that we need to do in order to process a document. Okay, so the document pre-processing can be divided into 5 text operations. So, for example, lexical analysis of the text, elimination of stop word because we don't want to include this in our vocabulary. We want to do stemming, select of index term, and then construction of the vocabulary. So if we look at the first one, basically this is the process of converting stream of character into stream of words. So we want to do the tokenization. So major objective is we want to extract word in from the document that we have. So normally we look at the space for the separator. We ignore the number. The hyphen breakup, the hyphenated words. We want to break into these 2 words, punctuation mark, and then case of letter. Okay, so all of these have different syntax and also carry some meaning. Okay, so when we have identified the words, then we can do the next one is we want to know which one is can be eliminated. So we want to identify which one is the stop word so that we can remove them. And this can reduce up to 40% or more. Okay. So this one is, okay, for this one, not able to retrieve document that contain this one because all of these are stop word. Too frequent that we eliminate them from the vocabulary. Okay, we also need to do this removing the plural, the S, and then removing the ing and so on. So this is what we call the stemming. So we want to only get the root word so that we can reduce the number of terms in our vocabulary. For example, this one coming from these 3 terms. So all these three terms will be converted to only one word, connect. Okay. So this timing process can reduce the size of the index in your vocabulary list, and this will improve the performance. Okay, from there, from whatever remaining term that we have, then we can select some of the term depending on your requirement. So for example, they set the text size, or they want to say which term carry more information by looking at the entropy. So they will set the threshold for the entropy and set the size of the text. What is the optimum size text? What is the optimum threshold value for the entropy? So based on that, we can limit the vocabulary that we have. Okay. So to summarize the whole process, the objective is to produce this. So we have the document. Today we talk about the text and the structure and the meaning. So we look at the syntax, we look at the structure, we look at the meaning, and we do the tokenization. We can remove the stop word. Okay, so we can perform the stemming. And when we have the control vocabulary are all those remaining terms. So what we can get here is that we can set the size. What is the size of the text? What is the optimum size? And what is the threshold for the entropy? Okay, so by doing that, we can reduce the number of index that we have here. Okay, so based on the text, we get the control vocabulary, and then finally we have the selected keyword here. So this is very important because you have selected this keyword because they would be able to retrieve the document more efficiently. So this is the lexical analysis, and then stop word removal, stemming, and then keyword selection. And then you construct your vocabulary.